Hello again, my name is David Riley and I am demonstrating my code for Challenge Assignment 2 in ECE 461/561. Now, Challenge Assignment 2 is different from Challenge Assignment 1. We will be, of course, still using the MSP 432 Launchpad board. We will also be using the educational board, Educational Booster Pack Mark II for the different components. This challenge assignment was to develop a home alarm system consisting of a fire alarm, burglar alarm, and doorbell using the components in the board and the booster pack and assigning priority appropriately. So the priority we were told to give can be shown here, where the fire alarm is given the highest priority of the three components, the burglar alarm has the second highest priority, and the doorbell has the lowest priority, which means anything with higher priority could override anything with lower priority and prevent it from running. So if fire alarm is running, nothing else will be able to run. We can see here we have like a quick breakdown of the system. As we can see, we have a couple inputs. We have 3 toggle switches, 2 of which were required. One I decided to add for extra functionality. So of course these 2 were on the booster pack, and they activate either the doorbell or toggle the status of the burglar alarm system between armed and disarmed. And this P1.4 toggle switch you might recognize if you saw my video on Challenge Assignment 1, where I had that be a reset button that triggers based on the watchdog timer. Now I decided to include that one in this project as well because the way that the booster pack is positioned on the board, it actually kind of covers awkwardly the actual default reset button on the board, makes it hard to press, and it is needed when the fire alarm triggers. So I decided to add an extra input there for that. Of course, we have 2 more inputs, the light sensor and microphone, which are based on I2C and ADC respectively. And those are new components we've been dealing with. And of course, our 3 outputs, similar to Challenge Assignment 1, we have a red LED and a green LED. Of course, these are different port and pin assignments because these are from the booster pack, not on the actual board itself. And then we have a buzzer that outputs sound depending on either a doorbell or one of the 2 alarms. So we go down to the main function. Of course, it starts off like most main functions you would expect. It pretty much just initializes everything here. So it goes to port init, which if you look at our ports.c file, initializes the GPIOs for the buzzer and the microphone, the 2 LEDs, and then our 3 button presses for the reset, doorbell, and burglar alarm respectively. Then if we have time init, which this is unlike Challenge Assignment 1, well, 2 things. First off, you can see we are actually using multiple .c files to help organize the different components of this project. And also we are implementing a timer, which was not required of Challenge Assignment 1, but is of this assignment. So if we go to timer.c, we can see where we initialize the timer, and basically we just set the timer to a 100 millisecond interval. So the timer triggers 10 times every second, which is not the most precise, but it's precise enough for what we're doing. It's fairly quick. Then if you go to watchdog timer init, this is pretty much also straight from Challenge 1 assignment. So we just set it to the watchdog timer, when it reaches its full interval, will trigger a hard reset, and we set it to a 1-second interval. Then we have our mic init and light sensor init, aka L sensor init. So if we go to our light and sound file, we can see here mic init configures all the ADC modules that will be involved to get data and be allowed to convert the data from the microphone through to ADC and then get that to the functions we need. L sensor is similar, but it looks a lot simpler actually because of the built-in functions. All of this data was from previous examples and other code that we did not write ourselves because I2C is a little complicated, so we don't need to know the intricacies of it, but these are the 3 main functions to configure the light sensor for the I2C. Now if we go back to main, of course we enable all our interrupts and timers, and then we get into the main portion of the main function, which is the while loop. So the while loop consists of two main sections. There's a static section and a dynamic section. If you don't know what that means, of course, static means that it does not change. It always runs in that same order, whereas dynamic means the components can run in different order depending on what happens. So first we, of course, have the static one where obviously we clear the watchdog timer to prevent a reset. And then we have these two functions here, get light and get sound, which you can see here. Get light triggers a conversion and then for the ADC and then puts that value into our variable ADC result. Get light does something similar. It calls this function here, which gets a value from the I2C and puts it in this variable lux. So every time it runs, we're always sampling for new values from our microphone and our light sensor. So as you can see here, we have a threshold value used for both the light sensor and the microphone sensor, and we set that value to 9,000. When I was messing around and experimenting in the environments I was sitting in, I tested the various thresholds for the light sensor and the microphone and found that 9,000 was an adequate value for both of them. So I decided to use one threshold instead of multiple. So this second part, like I was saying before, is dynamic and it is priority based. So as before I was saying, the highest priority is the fire alarm. So of course that component is first, and then we have the burglar alarm system here and then the doorbell here. Now these statements were partially inspired by the midterm problem set we had in class. The question came up of how to turn a round robin system of if clauses into a RTC system. What was the easy way to do it? Well, the easy way to do it is keep the initial if statements and replace the rest of them with else if statements so that they only run if the initial condition was not triggered. So that's pretty much what we have here. So we take our lux value. If it exceeds a threshold, then we enable the fire alarm to go off. If that doesn't occur, then we check these conditions here for the burglar alarm, which you can see looks a bit more complicated. It's an and statement within an or statement. So this is the main part here, because there's actually two prerequisites for the burglar alarm to go off. One is that, of course, the ADC value we get from the microphone must exceed the threshold, since that is always checked. And then, of course, if the burglar system is armed, the security system is armed, then the burglar alarm can go off. So that's what this value indicates here. And so when that occurs, it, of course, activates the burglar alarm itself, and it basically disables the doorbell over here. And that's where you can see B alarm enable, which indicates that the alarm is running, is also one of the conditions here. So if the burglar alarm is running and the fire alarm is not preempted, the burglar alarm will continue to run and prevent the doorbell from running here. So over here we have the doorbell flag, which occurs when the doorbell is pressed, and of course if none of these other conditions are met, and it clears that flag and enables the doorbell to ring. If we go back to our ports.c file, we can see down here we have our port interrupts. So for port 1, we of course have our reset here. This is almost straight copied and pasted, kind of like the watchdog setup from our challenge 1 assignment. The main difference being before we had an infinite while loop here when the button was pressed. Because of speed and power issues, or not efficiency issues really, I decided to replace the while infinite loop with this new function WT redefine, which you can see in timer here, which holds the watchdog timer and then redefines the value so that the watchdog timer, instead of having an interval of 1 second, has an interval of 15.625 milliseconds, much shorter, almost and pretty much providing what seems like an instant reset, and then it restarts the timer. So that's what occurs when the reset button is pressed. Then of course we're looking at the port 3 interrupt, which toggles the status of the burglar alarm security system. So this system actually did need a debounce, so of course when it's triggered it activates a debouncer flag, and then depending on the status of the system it'll toggle. So if the system is disarmed, it'll arm the system, and if it's disarmed it will arm the system. Of course we have the LEDs to indicate visually the status of the system. So LED is green if the system is disarmed, red if it's armed. So when you're arming the system, you alternate green off, red on, and then when you arm the system, or you disarm the system, red off, green on, as you can indicate here. When you disarm the burglar alarm system, you also disarm or disable the alarm if it's running. So that's where you can see here, when you're disarming the system, it checks if the burglar alarm is running, and if it does, it will then disable the alarm. So we already looked at timer, so now let's look at the main regulator here. We got the timer interrupt function. So first off, the timer that we showed you in timer.c that indicates a timer interrupt is timer A1, and that goes off every 100 milliseconds. So here we have this PWM timer, which is connected to timer A0. So that's actually what triggers the buzzer to go off. And by changing this value right here, you change basically the frequency that the buzzer goes off at, changing the note that the buzzer outputs. So the first thing we do in the timer interrupt is, of course, if a debounce is triggered, it activates the debounce, disabling the interrupt for the burglar alarm switch for 500 milliseconds, or half a second. So you can see, and before we re-enable it, we clear the interrupt flag to ensure that it is not up, because we don't want a delayed rebounce, and then of course deactivates the debouncer flag. Then of course we check to see if the fire alarm is due to go off, and if it does, then it of course disables the other two alarms, because you don't want those overriding the fire alarm. And then the fire alarm goes off at 0 seconds, 1 second, and 2 seconds. So when it reaches those points in the timer, it'll stop the buzzer very briefly. It'll change the buzzer frequency to the appropriate note as designated here, and it'll restart it. And then so that's at 0, 1, and 2 seconds. At 3 seconds, it'll turn off the buzzer, and at 4 seconds, it'll restart the counter. So it goes off in a 4-second period, with 3 times it's on and 1 time it's off. Then if you look at the burglar alarm, it checks to see if that goes off, and of course we'll disable the doorbell if that is triggered. And then of course it has, instead of going off in a 4-second interval, it only goes off in a 1-second interval, alternating between 2 notes every half of a second. And you can see here it's actually got 2 unique notes designated by these numbers here, which are of course different from the fire alarm. And then so it runs for time equals 0, and then time equals half a second, and then once a full second runs, it resets a counter. So it just keeps going in an infinite loop. Lastly, we have the doorbell. So with the doorbell, it only goes off, of course, if none of the other alarms go off. At time equals 0, it plays this note here, which is actually an E, and then after 1 second, it switches the note to a C, and it does. Notice there's no stop there because I wanted it to kind of flow like a natural doorbell. That's why it goes E to C with these 2 notes here, and then basically after 2 seconds, then it'll disable the alarm because it's not repeating like the other alarms. It only goes once, and of course it will reset the counter. So that's pretty much a general breakdown of the code. We can see it builds like so. And if we look here, we do have some advice down here, description for power. Most of these were dealing with some of the core functions that we were given. I didn't feel super comfortable messing around with those. I didn't want to, by trying to make it more efficient, actually disable and ruin the ADC or the I2C values there. And then of course it also recommends for power efficiency to initialize all of the uninitialized ports, but in doing so actually caused a higher power consumption, as well as had a couple issues with errors triggering as well. One thing I did do is I did look at the optimizer assistant and compare the speed versus size setting and use the best setting that it gave for me there. So that pretty much shows the code. So now I'm going to show it uploading and then running. Cool. Alright, we're back, and as you can see, we're pretty much where we left off. We have our code for Challenge 2 still here on Code Composer up on the computer. And now if we go down here, we actually have our hardware here. We have the MSP 432 board with the Educational Booster Pack Mark II attached on it. And so of course you can physically see the components we'll be using now. We have our two buttons. This button up here will be configured for the doorbell. This button will toggle the status of the burglar alarm system. We have our RGB LED over here. We have the buzzer output, microphone input, light sensor input, and then of course this button down here on the board that I've configured to be a reset. So I'm going to go ahead and plug it in and start debugging to download all of this code onto our board. And as you can see, you probably see a spot there on the screen. You'll see it again. The LED is actually quite bright on the system, so it loves reflecting off of stuff. So now it's debugging. Sometimes it takes a second. Alright, now the system is debugged, so we're just going to go ahead and run it. And you'll see the LED kick on here as it starts. There you go. So the system starts, the green LED lights up to let you know that the burglar alarm system is currently disarmed. So why don't we just go ahead and start off with the lowest priority. We'll start by testing the doorbell. There plays a nice 2-second jingle. If we have the button here for the burglar alarm, you can see it'll turn the LED red, indicating the system is armed. And you press it again, it'll be disarmed by a green button press, and you can just indicate that if it's red and we have a reset down here that turns it back to green, is a pretty instantaneous reset. So why don't we go ahead and first test the burglar alarm. So as you see, I have a little speaker here with some music ready to play. The system is now armed and the speaker is close to the microphone. So I warn you, this might be a little loud, so if you want to lower the volume while you're watching this for a few seconds, I'm going to play this tone and the alarm should sound. And you see the alarm sounds pretty quickly, and that is what the burglar alarm sounds like. If I press the doorbell button, nothing happens, and if I just push the alarm button, it disables the alarm and it says the system is disarmed, and then if I press it again, it's rearmed. Now if I go back to a disarm status, I have a little flashlight here. I'm going to shine it over the light sensor to show you the fire alarm works. And there, that's the fire alarm. That's what that sounds like. I can still arm and disarm the burglar alarm system, but it doesn't do anything. And the doorbell, of course, does nothing as well. The only way to stop the fire alarm is with a reset. And so it's hard to time an interrupt of the doorbell, so I'm going to prove that the fire alarm has higher priority over the burglar alarm by interrupting it. So again, I'll play the tone again to trigger the burglar alarm, so you might want to lower your volume. It's kind of loud. Okay, see now the burglar alarm is running, and again I will shine the flashlight over the light sensor. And you can see pretty instantaneously the fire alarm cuts off the burglar alarm. So we just go ahead and reset it again. And that's pretty much challenge assignment 2. The home alarm system complete. Doorbell, burglar alarm, and fire alarm. Thank you very much.